All right, today we're skipping all the high-level theory. We're going to dive straight into some real, actionable patterns for green multi-cloud design. This one's for the architects out there in the trenches, the ones ready to build not just for performance and cost, but for a sustainable future. So, I've got a question for you, and I want you to really think about it. Is the cloud architecture you're running right now truly energy efficient, or is it kind of wasteful? It's a huge question we often just push to the side, but we're about to find out why it matters more than you might think. Okay, first things first, let's get one thing straight. The cloud isn't some magical, fluffy thing in the sky. It's a massive, power-hungry network of very real data centers. And every single architectural choice we make is either pouring fuel on that fire or helping to tame it.
I mean, this quote really hits the nail on the head, doesn't it? Inefficiency isn't just about dollars and cents anymore. It's about carbon. Every idle VM, every forgotten storage volume, that's fundamentally wasted energy. And as architects, we're the ones with our hands on the controls. We have the direct power to change that.
So, what's the fix? Well, the good news is you don't have to boil the ocean here. It really all comes down to three core pillars of green design. Think of it as a framework you can start using pretty much immediately. Okay, pillar number one, this is a big one, and honestly, it's the one that gets overlooked all the time. Choosing your cloud regions wisely. We obsess over latency and cost, right? But it turns out that where your code runs can be just as important, if not more important, than how it runs. So the magic number you need to know is something called carbon intensity. Put simply, it's just a measure of how clean the energy grid is that's powering a data center. A region running on hydropower is going to have a way lower carbon intensity than one running on coal. Your job? Find the lowest number, period. And just look at this. The difference can be absolutely staggering. Just by choosing, say, a GCP region in Canada that's powered by hydro, you could slash your application's carbon footprint without changing a single line of code. You see? This is where a multi-cloud strategy suddenly becomes this incredible tool for sustainability. This is your biggest lever, right? All right, pillar number two. We have got to master dynamic scaling. We need to fight the biggest source of waste in the cloud, which is that old school, always-on thinking. We build for the busiest shopping day of the year, and then we pay for it in cost and carbon every single day. So how do you do it? Well, it's pretty straightforward. First, you've got to really know your usage patterns, the peaks and the valleys. Second, you set up intelligent triggers that scale with actual demand. And the holy grail, the ultimate goal, scale to zero. If nobody is using it, no resources should be running. End of story. And for our final pillar, it's time to go zombie hunting. Yeah, I'm talking about finding and destroying all those forgotten resources that haunt our cloud accounts, just sitting there consuming energy and money while providing absolutely zero value. Come on, I bet this list looks pretty familiar to just about everyone. These are the usual suspects, right? Orphan storage, idle test servers from 6 months ago, over-provisioned databases. This isn't a one-and-done fix. This requires making regular automated cleanup a habit to keep your environment lean and mean. Okay. Enough talk. Let's see what this actually looks like in the real world. We're going to compare a typical, kind of wasteful architecture with a much wiser, sustainable one. So first up, the before picture. And this is that classic anti-pattern we see all the time. A huge fleet of monolithic virtual machines provisioned for peak load running 24/7, 365. It's simple, sure, but it's just bleeding energy during nights and weekends when traffic is at a minimum. And now, the after. This is a thing of beauty. A modern, right-sized design. It's using serverless functions for those spiky workloads. They just scale to zero all by themselves. And small, correctly sized virtual machines that are scheduled to run only when they're actually needed for predictable jobs. I mean, the difference is just night and day, isn't it? We're moving from large and static to small and serverless, from always on to on demand. The result is a system where efficiency is the default because resources only exist when they're truly needed. So what does all this add up to? How about a potential 75% reduction in energy consumption? 75%. This isn't just tweaking a few settings here and there. This is a fundamental architectural shift with massive payoffs, both in cost and in carbon. You see, this all leads to a new way of thinking, a new mindset. We have to start architecting a greener future. We need to make sustainability a core pillar of our designs, right up there with performance, security, and cost. It deserves a seat at the table. So here's your checklist, your cheat sheet for green architecture. Number 1, choose low carbon regions. Number 2, auto scale to perfectly match demand. 3. Schedule your non-critical workloads. 4. Embrace serverless patterns. And number 5, make auditing for digital waste a regular, automated habit. Those are the 5 keys to a much more sustainable design. So I'll leave you with this question. Looking at your systems right now, what's the first tangible step you will take this week to reduce your architecture's carbon footprint?